All right, hi. So today I'm just going to show you guys kind of what I expect from these silly walking graphs. Yes, so I'm going to try and be as quick as I can. Empty promises, I know, but I'm going to try my best. Okay, so here I've already set up a little bit of kind of what I expect, but then I'm going to write along here with you. So one of the things I definitely expect is for a descriptive title. So here's my graph. And it's got a descriptive title. It tells me it's a position versus time graph. So in science and in physics, we title graphs basically as the vertical versus the horizontal. So the vertical here, I've got position, and then on the horizontal, I got time. So it's a position versus time graph. But you want to be more descriptive than that. What kind of okay, it's a position versus time graph, but what's the object that's being studied here? In this case, it's one of my students, Carlos. You won't be looking at Carlos this time. You're going to be looking at another video. But yeah, this is a position versus time graph of Carlos. Yes, and that would be a descriptive title there, so that's good. And then the position is, the position here is measured in meters. That's on the vertical, so that's a well-labeled axis. Time is measured in seconds. That's another well-labeled axis right there. Awesome. Whoop. Got rid of the P in position. Okay. So, and then the axes are in evenly, one thing, well, yeah, they're in even intervals here. And they're also in even intervals here. Here they're going in increments of 5. Here they're going in increments of 2. That's okay if they're different from each other. But once you have an increment on, say, the vertical axis, keep consistent with those increments. And once you've got increments on the horizontal, be consistent with those as well. So you don't want to fluctuate those. You also, no broken bar graphs in this class. So it goes all the way to 0. So yeah, you can't do any of those broken bar graph type stuff. Okay, so I've got my data already plotted out. Oh, one other thing I wanted to mention is that the axes themselves should use a straight edge. You should use a straight edge to generate your axes and your best fit line. If you got access to a ruler, awesome. If not, use any kind of straight edge, a book. Anything. Okay, so now I'm going to make my best fit line because I got this data. It looks like it's generating a linear line, so I'm going to make a linear line out of that data. I got a fancy tool here. There we go, right there. Probably going to do something like that. And whoop. Awesome, there we go. Now, on the AP exam, they're quite particular about this. Basically, when you generate a best fit line, if you got data, it fits a linear shape, and you make a best fit line out of that, often what the graders will look at is they'll say, do the data points above essentially match the amount of data points below? To see, does your best fit line actually take that best fit right there? So you want to be, don't stress out too much over it, but you want to be good about that. Now, we're also going to calculate the slope of this graph because what's cool about science is that things like the slope of a graph actually have physical significance. There's meaning in doing a calculation like that. So let's see what that looks like. Now, when you calculate the slope of a trend line or a best fit line like this, you want to make sure that that you choose points on the line and they cannot be data points. So you're choosing points on the line and they cannot be data points. Okay, what I mean by that, let's choose this point right here. You want to mark it with an X so that you know, so that the person who's grading this, again, it's kind of preparing you for the AP exam, the person who's grading this knows, oh, they're choosing points, and it's not a dot, it's marked with an X, so those are the points they're choosing to calculate their slope. And then let's also I'll do this one right here. So those are the two data points that I've chosen. I'm sorry, not data points, the 2 points that I've chosen to calculate my line. Okay, this data point I'm going to approximate, I'm going to say it's at, so I'm going to label it here. It's 5 seconds That's the horizontal part. And then, let's see, in the vertical part, I'll say it's like 1.8 seconds. I'm sorry, 1.8 meters, right? Because that's where that is. Okay. Now for this one, I'll say is this data point is at 35 seconds. And then somewhere about here, that's about we'll say 9.6 meters. And now I'm going to calculate the slope of this. So I know it's been a little while with calculating things. So for a slope, I think I might be thinking M is often a symbol for slope. Some people say it's rise over run, or you could run, or it's the change in the vertical position versus the change in horizontal, which is kind of strange because we're going to try not to use this notation because the issue being is that position, the unit we use to measure position, or the variable we use is x with a vector arrow over there. I'm not going to worry too much about vector arrows right now for this case though. So we use x as the symbol we use for it. So it'd be the change in x over, and then the symbol we use is t for time. So over the change in time. So I know typically your x in your math classes has been on the bottom, but because we often use x to label position, sorry. So it's going to be, let's see, if this will be t, I'll call this t2, and this is x2. So time 2, position 2, and let's make that gray. And then this will be time 1, position 1. And now I'll do that calculation. So it's going to be 9.6 meters minus 1.8 meters divided by 35 seconds minus 5 seconds. And then you'll do that calculation. I leave it to you to figure out what the units are for this value that you're going to calculate. But this kind of work is exactly what I want to see on everybody's graph. I should see, all this stuff. Detailed description, a descriptive title, axes well labeled with units. Your axes also use a straight edge. Your best fit line uses a straight edge. And then there's work to calculate a slope that ends with a number that's got units at the end. So I don't want to spoil what the units are. That's for you to do. On the front page is going to be, you're going to have two graphs. One, so you might just say position versus time of, two people. Where here you'll say is someone, person 1. Feel free to say who that person is. But then you'll have another person that has like, here I'll do, let's say here's new data. If you could do a different color or something like that, or different way to draw it, that'd be great. And then, so on the same graph, so this is for video 2, it might look like that. That's not very good. It's probably a better fit. Maybe like this. Doesn't necessarily, there we go. And then you're also going to calculate the slope of this one. So, and then you'll calculate the slope of that, blah, 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 blah. So you'll have two slopes on the front page. And then on the back page, again, you just got one video you're collecting data of. But you're going to calculate the slope or slopes, depending on how you choose to interpret that data of that. So, yes. All right. Hopefully that was helpful to you of what I expect to see. I should see, again, one graph on the front page with two sets of data. So here's one set of data. Let's make that a little. Here's one set of data. Here's another set of data. But then on the back page, it's just data from the one video, from the last video, and then calculations of slopes there as well. Sorry, I wanted to add one last thing about why we don't choose data points. as points to calculate slope. Because let's say I chose this, let's make that a different color. Let's say I chose this data point right here and this data point right here. Well, I would make a line, I would be calculating a line then. I'd be calculating a line that looked like this. So I'd be calculating a line that looks like this. And does the slope of the blue line here match the slope of the yellow line? Not at all, not even close. So that's essentially why you don't choose data points to calculate your slope. It's just bad form. And yeah, you're going to get that slope isn't even close to the other slope. Which the yellow line better fits the data. So you want to choose points on the line, and it's considered bad form to choose data points even if they are on the line. Yeah, so there you go. Okay, thank you. Bye.